Ooh, alright. Let's see now. Neural chess engine that comments on everyone's moves. What up? Yo, what up, y'all? Okay, statement from Mark Zuckerberg. Do I actually want to read this? The SCV that took down was the worst outage we've had in years. Blah, blah, blah. I guess this is in relation to the whistleblower who's like saying that what's it called? That Facebook actively promotes I guess negative content to increase engagement, but at the heart of these accusations is the idea that we prioritize profit over safety and well-being. I don't know. I mean, fundamentally, every single business prioritizes money over everything else. So, not sure I buy that, but I guess it's just like for social commentary, and just to be the face of the company. Okay, I get it. To me, if you go on to like, if you look into like what Facebook does for content moderation, it's pretty abysmal. Like for instance, like a lot of the fucked up things you see are usually just filtered out by content moderators who they themselves who will like literally look at some really horrid shit and then like suffer PTSD because of it. And from what I know, Facebook doesn't um, actually cover the mental health aspect of that. Really, the quote unquote mental health stuff that they do provide is really more so like, hey, get back to work or some shit along that lines. But at least that's based on what I've heard, and based on what I've read, like through interviews like on Vice, where they've actually interviewed people who do content moderation for Facebook, and usually that shit is like always done outside the U.S. because it's just what's it called? It's just way less expensive to hire people to hire scut workers to filter through all the content here. So the argument that we deliberately push content to make people angry for profit is deeply illogical. We make money from ads, and advertisers tell us that they don't want their ads to be harmful or angry. I don't know any tech company that sets out to build products to make people more angry or depressed. Bruh, fucking Chamath, man. You get engagement through angry people. I the whole Cambridge Analytica saga was actually about Russian trolls who would literally engage people on the platform with basically heinous fucking remarks. And it's hard to make that argument. I understand from Facebook's perspective that it's really difficult to manage this kind of shit, but it's also in Facebook's benefit to do so. If you can get people emotionally charged up, you can get them engage on your platform, and that's ultimately what a lot of the Silicon Valley model for businesses has devolved into. So while he can say this, it's like kind of he can say that, but at the end of the day, getting people to actually engage with this kind of negative shit actually benefits his platform. So overall, this statement, as I keep reading it, is just that it just keeps reading like some guy trying to be a diplomat for his company, even though technically all the stuff that happens is beneficial to him too. It's really hard to. It's really hard for Mark to really put any justification for a lot of the shit that you've seen on social media or the way Facebook handles things. So I understand like where he's coming from with this, and I understand why he's doing it. It just screams a little hollow when the incentives are so convenient. But I also understand that Facebook, dealing with the scale that they're working with is actually pretty. It's going to be very difficult for them to actually come out and be very genuine about like handling these situations. So, does Uber use Spring Boot? I don't think so. As far as I know, Spring Boot is mostly used and favored by full stack developers, but I can't really speak to like the back end of things. So, Facebook. Okay, this is more or less the same thing. Facebook whistleblower leaks thousands of pages encrypting internal docs. Um, Again, it's like the amount of skill that you're dealing with makes it very difficult for Facebook to even do anything. I'm not trying to defend Facebook here, nor am I saying that or incriminate them either. I'm just trying to get people to understand like why this situation is so difficult to even manage for someone like Mark. It's like we're literally trying to come up with rules that fit the entire fucking globe. And we can't even do that for politics. What much less some private tech company is going to be able to do it. It's really fucking hard to to monitor and legislate that many people at once in an effective manner. Tab unloading in Firefox 93. Nah, not interested in that. Timescale announces new database cloud. Open source alternative to Google Cloud. Oh. Oh. Oh, Stripe Press. What the hell is this? This was interesting. Oh. Oh no, this isn't actually Stripe. This is just. Wait, no, it is Stripe. What the fuck? What the fuck is this? What am I looking at here? Okay. Let's click on this. Let's see what high growth handbook is. Oh. It's worked with high growth tech companies like Airbnb, Google, Stripe, blah blah blah. Scaled from startup companies, global enterprises across companies. Gil has identified a set of common patterns and compiled them into a repeatable playbook called the High Growth Handbook. In this definitive guide, he covers key topics for scaling startups from 10 to 20 employees to thousands, including the role of CEO, blah, 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 blah. Oh, okay. I get it now. Stripe Press is just literally just a collection of books for people. Stripe partners with millions of the world's most innovative businesses. These businesses are the result of many different inputs. Perhaps the most important ingredient is ideas. All right. The systems of engineering management. I'm gonna be honest. I'm not very interested in like engineering management, but this one looks pretty interesting. Big score. Where's my flying car? I would say the learning to learn is gonna be. This looks like a very interesting book actually. What inspires a great idea? Can we train our thinking to develop a world-changing understandings? Hamming would say yes. In art, science, and engineering, he outlines a seminal essay, you and your research, a provocative challenge to anyone who wants to build something great, or offer a manual style for how to get there. Playfully framed as a textbook and rich in his recount of influential individuals like Albert Einstein and Grace Hopper, this unorthodox memoir by the seminal mathematician and engineer encourages the reader to aspire to learn from and surpass the achievements of just these great minds. Yeah. I would definitely try reading this, although I think it's more or less similar to, Charlie Munger's mental models. And I feel like if you watch enough Charlie Munger's interviews, you kind of get a sense of like how he learns. I think he's like legitimately like not just like one of the best investors in the world. He's also a really good guy to like learn from. And in fact, like some of the other really good investors like Monish Parbrai, like literally like spend thousands of dollars just to have lunch with him and just to meet him. So I remember you advertised new grads to prioritize growth. I am deciding between Lyft and Google new grad offers. At Lyft, interns seem to reach senior in 3 years fast, and Google's slow but G-brand. Any advice? I think like between Lyft and Google, it doesn't really matter at the L3, L4 level. You can advance to senior. That's just a title, though. The question is, what are you doing as an engineer? You can be an L5 senior engineer and not know or do jack shit. I've seen that before, where engineers literally don't understand the code that they're writing or understand how to think about products. So they can be quote-unquote L5 in title, but if they don't fucking understand how to do proper engineering or how to properly think about these systems or understand them, then really that L5 title is meaningless anywhere else. And so ultimately what I would want you to consider isn't the company, it's the team you join. So if I were you, I'd go back with those offers. I'd try to talk with exactly the teams that you are going to match with and work with, and then try and get a feel of it to see the kinds of people on the team. So for instance, are they the kind of person that you would want to work with 3 to 5 years from now? Is the team, constantly changing? Does the team believe in their own work and their own product? It's the people that heavily invest in that, who believe in their own team and product and believe in themselves enough to stay there and to constantly learn. That's the best environment. So Lyft and Google, fundamentally, the engineering is going to be pretty much similar. The difference is going to be the people you're surrounded by. Like in any company, there's going to be good teams and bad teams. Good teams that are really, really engineering efficient and can teach you a lot. Bad teams who don't give a flying fuck. So I would say at this point in your career, pick the right team and make sure you find the right people who legitimately care. That's my best advice to you. Is senior level from Uber and Airbnb equally transferable to Facebook or Google? In theory, yes, actually. So if we go to like levels.fyi, and I put up like Uber up here, right? Uber, blah blah blah, and let's add Airbnb. So you can see here, like approximately the L5s across the bands are going to let's take out Microsoft for this comparison. L5s across the bands are going to be pretty similar, and you go to any senior software engineer at Uber's Facebook page, not Facebook, but LinkedIn page, and you will basically be able to hand that over to an L5 anywhere else. I think that's pretty evident. I think the tricky part is when you start getting to L5B. You know, the compensation bands for L5B is actually much higher than staff engineer as well. So let's take a look at this. 49 for Google, and then 553 for Uber, which is, you know, that speaks to some of the risk profile here, but it's also a little bit weird. I would say, like, based on what I've seen, I would say L5B is definitely correct, like, to situate this here, because once you hit staff, it's a little bit, you get a little bit more responsibility, and I would say our staff or engineers at Uber are fucking fantastic. So, but with that, I think it's about time for me to bring in our guest, my client. So, give me a sec, guys.
Recording in progress.
Okay.
Recording stopped.
Okay, let's see if our guy joins. Okay, Saul asks, hey, do you have any recommendations for learning data structures? You mentioned grokking and EPI, but that seems more like patterns. Honestly, pick up a freaking textbook, man. Like, there's plenty of courses on, like, Udacity and stuff that'll teach you data structures. Like, heck, even your college course should have taught you that, to be honest. But any textbook will really do. Like, for instance, let's see. UC San Diego, what's it called? If we go to, like... Yeah, if you go to, like... I feel like this should be, like, a freaking free textbook. God, I can't... What is his name? It's like some Berkeley professor, actually. Oh, man, what's his... data structures and algorithms, no. No. Hold up. Let me find that textbook, because it's pretty freaking free. Interview practice diaries. Okay, so if you guys really want like a quote-unquote textbook, this one, Open Data Structures, is still pretty good. Like, it's fucking free. Like, you don't need to pay for this shit, guys. Like, I don't know why people fucking pay for courses that are like $5 that you can get for literally fucking free here. Like, seriously. Like, oh, you want to talk about linked lists? Hey, here's like the fucking code for finding linked lists. Here's how it's done, and here's like the fucking time-space notation, man. So this is like a free fucking book, man. And then if you really need like slides to go along with it, here are the slides that I think I used when I was in college. So here are the these UCSD slides. They talk a lot about like what's called like Huffman coding, how C++IO works, input output, binary trees, and all that good shit. So I think my client is taking a little bit of time to join, so he has a little bit of trouble. So hold up, let me go ahead and get him on the. I think he's gonna have to join through Discord. Hold up. Yo, hello? Hang on. Oh, there we go. Hello?
Hello.
Yeah, I can hear you. What's up?
What's up?
Hey,
I'm doing good. Not much. How about you?
I'm doing all right. Yourself? Yeah. So say hello to the stream.
Hello, stream.
uh, but yeah, I guess you can introduce yourself to everybody. Let people know like who you are, how you found me, and like what your whole situation is.
Oh, for sure. My name is Mateus. I'm a third year student in information system here in São Paulo, Brazil. And yeah, it should be like the fourth year, but I just like delayed my graduation. But yeah, anyways. And I've been like trying to apply to a few internships at FANG companies. I did like a few interviews on when I was the second year, but I did not succeed. Was not like trained enough for this. And I have like two internships, two in like companies and one in university in Pennsylvania. And in my first internship was more like web development stuff, those kind of things, .NET. And the second was more like a data, like related role. And the third one was more like, yeah, a development. I like spend like a few months like creating a framework in Unity, like this framework that uses C# and stuff. And yeah, that's pretty much a little bit about me. And yeah, I've been training since January, but I discovered your channel like in May, was like April or May, through this guy called Trend Black, and he said that you coached him, and I started to watch your videos, and I read your ebook, right? And I found a lot of good insights. So there's a lot of things that I had to improve. And since then, I've been following like the your advices like that you say on the videos and like you write there, and it's been helping me a lot. And like last week, a recruiter from Facebook reached out to me, and I think to myself, well, I had to like use all that I had in my favor to like pass in this interview. So because like last month I got like bumped on Amazon coding assessment, right? It was like a question, advanced question, like to find the minimum spanning tree in a graph. So I think to myself, well, I cannot miss this opportunity right now. So basically, that's the whole picture.
Got it. But you've done a lot of internships before, and I think you said you had a Google phone screen as well, right?
Oh yeah, I was like in the second year, but I definitely was not like prepared. I was like only in this vibe. I was like starting to discovering this kind of code interview stuff, and I just applied. They accept me for this phone interview, but I just got like was a disaster. Yeah, I was not like anything prepared for that.
Understood. Yeah. So you have 2 weeks to your phone screen, correct?
I would say like 1.5 now.
Holy shit. Okay, we got a 1.5 weeks to turn. That's okay. I'm gonna tell you right now that in 1 week I can fix one habit, one or two habits. That's it. The rest will be like whether or not you've been prepared properly or not. But let's do what we can, and hopefully it works out. So let me share with you the doc.
Okay, great.
Yeah, I just want to put a disclaimer out there. I can work miracles, but you got to give me time, you know?
No, for sure. My intention was not like to have a miracle. It was just like to see if the whole path that I did until now was like kind of correct, and what can I do better for like the next, like the same thing you said on the email.
Okay,
yeah,
got it.
Basically this. All right, here I am in the doc.
All right, cool. Let me bring it up. All right.
Perfect. Oh, can I just tell you a little bit, just one thing?
Yeah, go ahead.
I don't feel so comfortable with, because I'm studying this last week, dynamic programming and recursion. So
don't worry.
I was just.
I'm not gonna. Okay. I wasn't planning on asking you that unless like I was having a bad day.
Oh, okay, okay, great.
All right. So let's go ahead and do this problem then. Let me bust out the timer. I'm sure you're familiar with how this works. So,
oh yeah, totally.
All right, cool. So let's see. Timer. Stopwatch. Is it showing here? No. Cool. Perfect. Okay. All right. Damn. Oh wait, let me turn this one off. Okay. Yeah, give me a sec. This window got blown up.
No problem.
Yeah. Okay, I see what happened. It resizes everything. God damn it. Okay, cool. So then I'm gonna start the timer. So this problem might look familiar to you, but again, I don't care. We're mostly evaluating you based on like your logic and problem-solving ability, because if you do that right, then you'll be able to solve any problem. So.
Oh, great.
All right, cool. So, suppose that I'm giving you a non-empty binary tree, and I want you to find the maximum path sum. So, for this problem, a path is defined as any sequence of nodes from starting node to any other node in the tree along the parent-child connection. The path must contain at least one node and does not need to go through the root. So, for instance, let's say I've had this path 2, 1, 3, right? Or this tree 1, 2, 3. The maximum sum is going to be 2, 1, 3, right? Because you want to conclude all these numbers. So,
okay.
And next one, but let's take a look at the bottom one, right? The maximum path is going to be 15, 20, and 7. And when you add that up, that's going to be 42. Now, why is this the case? Because you're not going to, you don't necessarily want to include negative 10 and 9. So, with that, I turn it over to you.
Okay. Just one thing, so I can like understand perfect. The 9 is not going to be included because it must contain like connection, right? So it's going to be 9 minus 10 and like 20. So we're just counting the nodes that are connected. So like 20, 15, 7. Is that correct?
Correct. Remember, this is just a path, so the nodes do have to be connected. You're right.
Oh, okay, great. Sorry. Anyways, the first thought I'm thinking here is, let me just basically try to understand first, how can I do this? Well, I think if we like traverse this tree, like counting until it sleeps and like counting the total sum, maybe it's not gonna like resolve in nothing. Let me just try another thing. Let me just put the other like side by side if I see a pattern here. Well, okay, basically, let me just think. Basically, a way to traverse this tree and like remember the other branches that I already traversed. Let me see if that's gonna help me. So I'm gonna traverse 1 to 2. Okay, so it's gonna be 1 plus 2, and then suppose that I go back to my root, and like since I already visited my first node, my root node, I'm gonna sum up to 3. So this is like the total sum. That's gonna be 6. Okay, yeah, that is the maximum path. But for this one that have a negative number, so for example, let's say that I'm gonna start to traverse from the left branch. So it's gonna be minus 10. Oh, actually, yeah, minus 10 plus 9. Okay, so here I'll have minus 1.
Okay.
Okay, and then I will remember, like, in some way, try to remember, maybe while, like, doing the algorithm, I can use, like, array or something, but let me try just to figure out how to solve the problem first.
Okay.
And then, okay, I'll go back and sum the 20. Okay, sum the 20. And then, yeah, traverse to the 15, and then the 7. Okay, but, okay, the output should like, let me just clarify just one thing. The path must contain at least one node and does not need to go through the root.
Keep in mind, it's a path. And what you did here is not necessarily correct. What you did is add up every single number, and then you decide to split. Remember, let's go back to the definition. So, is that it's a connection between along the parent child. You start at one node and then you end at another node. Does that make sense?
Yes.
Okay. And what you did was you ended up ending at two nodes because 15 and 7 could be if you start at 9, then 15 could be an end and 7 could be an end. You only need one end. So.
Oh, okay, I got it. Yeah, I should consider that thing. Yeah, in this case, like I'll have 9, 15, 7, so it's like 3 and like 2, yeah, 3 ends, so it's not gonna work. Well, must to contain at least one node, does not need to go through the root. Okay, basically, just one thing. So I still like not, just one thing I think it's not clear for me. Like it must to give you the maximum path. So I should give you like, should output the nodes of the paths, or like the output should be like the maximum sum, right? Is that correct? The maximum sum.
Yeah, how about this? I want you to give me the sum itself, the number.
All right.
I want you to give me the number. Like, so, looking back at the examples that I gave you, I said the output is 42, so that's the number, so.
Okay.
Okay, so.
So, yeah, let me try to start over.
Okay.
Like, just my line of thought here. So, I'm gonna be, what can I do is like, just a normal traversal, like go from the 10 to the 9. Okay, this is gonna be a path, and then I can disconsider this and like consider like, yeah, the only thing I'm not understanding, it's not so clear to me, it's because, okay, I can have a path like 15, 20, and 7. It's valid, it's 42 here. But, no, it's, okay. I should not consider the 9. Yeah, just this part is kind of not clear for me.
What part is not clear?
The part that is not clear is, how am I gonna disconsider the 9?
Okay, how do you not consider? Okay, got it.
Yeah.
So, okay. So, let me help you a little bit. What is the most brain-dead simple solution that you can think of? Like, it could be super giga inefficient, but can you come up with a way to get the answer? Let's start there.
A way to get the answer is try like maybe all the combinations, all the sums, like of the nodes of this tree.
Okay.
Right. So I'll try 15, 20, and 7. It's gonna be 42, but I can try like 9 minus 10 and 20. It's not gonna be 42. It's not gonna work. So, but.
So your real question here is like, well, okay, let me see if I can help you in the right direction. So you said earlier that you want to try every single path, correct?
Yes.
How are you what's your algorithm for generating the path?
I was thinking in like in order traversal, just like DFS.
Okay.
So, but what I was wondering is like, how am I gonna keep track of like this information of the sum, and like disconsider like in this case the 9. So for example, if I'm not gonna draw like, but I'm just gonna put like a few examples. So if I have like, let's say 1 here, and 2 here, I can have like 2, 1, 3, 2. It's gonna be the maximum, but I cannot have like 2, 1, 3 minus 1. It's not gonna be valid.
Correct. So then
the thing go ahead.
I was gonna say, so then how are you gonna account for that? How are you gonna be able to say, hey, what if I went the wrong direction? Or what if I picked the wrong path?
I think, well, I think maybe I can have like a sort of a variable to like keep track of like the maximum uh, the maximum value of path that I already traversed.
Mm-hmm.
So for example, what I was thinking is like, so I'm here in the route 1, gonna traverse to 2, do the sum, go and then go back and sum the 3.
Mm-hmm.
It's like it's gonna be bigger, and then go to -1. Oops, it's not gonna work.
Mm-hmm.
So like do the backtracking thing and go to the 2. Okay, so here's the maximum. So yeah, I think it's kind of something like in this way. But let me see if that's gonna work for this first example. This one is like worrying. So here I am in the -10. I'm gonna try to sum to the 9, it's gonna be -1. Okay, that's better than -10. Then I'm gonna go back and try like to the 20, like -10 plus 20, gonna be 10. Okay, that's better. 10 is better than -1. Okay, so I should go in this path. And then I'm gonna go to the 15. All right, that's 25, and then plus 7, 42. Yeah, and then so I will be outputting like the maximum sum that I found. So basically, I think that's what I was thinking.
Okay.
Yeah.
Sure.
So just let me outline my process to do this.
Okay.
So basically, do a traversal, like a traversal, keeping track of the longest sum found, like the longest sum found. I'm gonna put like this, and if at some node it is smaller, it's smaller than what I found, what I have found. Yeah, don't consider, and like yeah, just basically that's it. Have a variable, and like to keep track of the maximum path that I like, the maximum path sum that I can make, like while traversing. I'm not 100% sure.
Okay,
like-
right now, the reason why you're not 100% certain is because you have a very broad stroke idea. Because, for instance, you say do a traversal, keep track of the longest sum found. Okay, that's great, but then how are you going to order this traversal? What are you going to do at each step? How do you know when to go into the next leg and so on?
Okay,
You understand? You understand what I'm saying here, right?
Yeah.
Okay.
I think I told you like back like in the first minutes, like when I was starting to understand that if I go in a path that it's smaller, then like I'm not going in the right path. So
Okay.
I should like to have a way to keep track of this. So
Okay.
this is not the right path to follow. So
Sure.
I better go back.
Okay.
But yeah, I think you're right. I need to consider those things also. Just a minute. I'm gonna put here.
Uh-huh.
Yeah, let me think. So I need to consider also. Okay, what I found, don't consider, and what? Yeah, smaller than I found, don't consider. Don't consider, and if not considered, I was thinking maybe not to move, like not to like compute more, not consider the branch, or start over. Maybe let me just see one thing here if that works. Okay, let's say that I have a greater number here. Let's say I have 90 and like, let's say 1, not here. Just mess it up the whole tree, but yeah, I think you understand. So now my biggest is gonna be 100, right? So 90 plus 9 plus 1. Now I should have to consider like, okay, I'll start to traverse here, and inside, in the left side, I'm gonna count like 100. And yeah, but when I'll backtrack this, I'm gonna start to decrement like while going the backtracking, like while traversing, I should like disconsider this 90 from like my total sum.
Okay.
And like starting my sum all over again here. And here I'll have 42. That's not gonna be greater than like 100. So
Okay.
I'll
I'm going to
output
put a
100
pause
for
here because you are
myself.
going to run into some significant issues. Let's start with what you just said. You said you want to keep track of a running sum, correct? And then it's like if you need to backtrack, you decrease the sum, correct?
Yeah. Correct.
Here's the problem with your approach. What you are going to end up doing is you're going to have to start with 90 and then go up to 9, then go up to -10, and along the way you're going to have to go up your tree and then you go down the other side of the tree. This effectively means that your tree and children is going to get more complex because each one needs to know about the other. So the parent needs to know about the child, and the child needs to know about the parent, because then you're going to need to do the backtrack, right?
Yes.
Like for instance, how do you know this 90 needs to go up to 9? And then the next, not to mention, this is only one of the paths you need to do. You also need to try the 1, 9, -10 path as well. Not to mention, you also might be in a situation where 15, 20, and 7 is still the correct solution. And so while do you understand like where the fundamental problem is going to come in? It's going to be a little difficult to go through every single node. Now, it can work, but I'm just giving you a caution. So.
Yeah, I see the problem here. Yeah. Maybe. Okay, I understand like the caution. Let me just think. What can I do? Well, like doing the traversal, I need to find a way like to do a traverse in this tree to count the nodes. I think there's no other way I can do this. Like thinking about like the traditional tree traversals that we have. So in order traversal, let's see if this is gonna help me. So 99 and then 1. I'm just seeing if like I can find a pattern like in the traversal. So for the in order traversal, we're gonna have like a 91 and 1. No, yeah, sorry. 99, 1, and then -10. And then yeah, 15, 20, and then 7. So yeah, I think I don't have to write, so I just can like
Okay, so what are you planning on doing with this array produced by the in-order traversal?
I'm just trying to see if there's a way I can like some results in a way, if I can like found a pattern or something like that can help me to like know that they're connected. I'm trying out my possibilities.
Sure.
So, if I do pre-order traverse is not gonna help me. It's gonna be the same thing. So in order, so a post-order traversal is not gonna help me as well. So okay. Yeah, I think that's not gonna work. Just thinking like one thing is for sure, I have to traverse this tree and like check out these nodes. But I also need to think about this like the path are the way that the nodes are connected for me a path. I think that is like my biggest problem, I guess. Maybe I know that is not so right to say this, like, but I'm just trying to see if I do like kind of a breadth first search here. What can I do? What can I get from this? So to know like the neighbors and the nodes that are connected. So if I start like a breadth first search here, let's say I'm the node 20. I know that
my children's are gonna be the 15 and the 7. So I'm gonna sum up all those things. And
Well, you're not necessarily guaranteed that the numbers are at the same level, you know? Because, so for instance, let's say I made your entire tree negative, right? Like, let's say I have this situation going on. Well, then, the sum is going to be 15 plus 20, right? So you're not necessarily guaranteed that 15 and negative 7 are included just because they're on the same level. So, oops. Yeah.
oops.
Oh, yeah, go ahead.
Yeah. Let me try to think better. Like, what can we see here? Like, yeah. I think. No, let me think first before speak.
I kind of know where you're gonna head with this, and so I'm gonna give you another, let's say 3 minutes, just so we're not wasting time. But I know where you're heading with this, and I know you're not gonna solve the problem. So.
Okay, great.
No, I'm serious. I already kind of knew, but we'll go over it later. But yeah, you got 3 minutes, bro.
No problem. It's part of the process. Okay. A breadth first search here is not going to help me because, as you said, it's not guaranteed that the nodes are going to be in the same level because I can have a node, like let's say another like children in the 7, and I'm not going to count. Yeah, I think the more like obvious thing for me was like to keep track this with like this variable.
Okay.
So I can know like the biggest sum, but it's not guaranteed, as you said. Like the other scenarios. Man, I'm like sure.
Look, you can throw in the towel if you completely are gone. It's fine. Like.
No, I'm throwing the towel because. Sorry about that, but
it's
yeah.
Fine. That's what you're here for.
I'm better like to learn through my mistakes.
Okay, it's fine. No, wait, don't worry. I'll stop the clock. Give me a sec. All
okay.
Right. So, I want you to do some self-reflection and self-evaluation. What do you think you did right here? What do you think you did wrong?
Okay. Well, I think the thing I did right was like try to play with the examples and like create another cases with the example that was given me. Like, and not just be stuck in like one easy example. But what I did wrong, like as I did, like this is like a common pattern in my behavior. Sometimes I get lost in my thoughts when I don't see clearly a solution. And one thing that is one difficulty of mine that I'm willing to improve is sometimes I have like a hard time to derive the answers based on like the preconditions.
Okay.
Yeah. So basically, that's the general view of mine.
My interpretation of what you did wrong is that you're looking for a magic bullet. You've probably heard me say this before, but basically you have the symptom of, hey, if I see this problem, then there must be some magic data structure or algorithm that I can throw at the problem in order to solve it. And this is like one of the reasons why array problems, and I guess to an extension some tree problems, can be very difficult to solve because, you know, it's not going to be solved in one easy, clean step. So let me actually paste my comments and mistakes that I foresaw. So,
okay.
And let's go over them. So around 3:30, say, okay, array or something. This is where my first inkling of you might have the magic bullet problem might occur. So you were talking about like, oh, what kind of data structure can I use to solve this? And I mean, it's not necessarily bad, but for me, it's just like, are you trying to solve the problem, or are you just trying to throw a data structure at it and hope that an answer falls out? That was the first little red flag. But okay, after that, you were trying to really understand the problem. It took you some time, which I'm not against. And again, it's just like a small little thing. If you need to take more time to understand the problem, no problem at all. But I think it's just the combination of factors and the way you were talking about the problem was leading you to understand that, hey, you're not really trying to understand the problem. You're really trying to look for a data structure to just throw at the problem and hopefully some answer falls out. And then I had to kind of clue you in on like what's the simple solution and could you use some backtracking mechanism. And you kind of got the hints, you know, you were starting to roll with it. but then you eventually kind of like abandoned it once you did, and the answer wasn't obvious. So you did like the broad strokes here, right? Do some traversal to keep track of the longest sum found, but then the next logical question is, what does that traversal look like? What are the rules for that traversal? And how the fuck are you gonna like, massage this to fit a general use case? These are the questions that you need to start asking next. And to me, and the fact that you gave up on it kind of shows me that you are not comfortable with being able to improve and optimize naive solutions. So this is more so not a what are the preconditions as much as a hey, am I willing to optimize on a naive solution? Like your problem is just getting to that point. So in this situation, let's suppose that I was you and I was stuck and I didn't know what the fuck to do, right? So for me, I'd be asking myself, why am I stuck here? Well, because let's start taking it from this point. Do a traversal, keep track of the longest sum found. If at any node it is smaller than what I found, don't consider it. Okay, what is getting you stuck at this point? Let's roleplay a little bit. Why are you stuck here?
Because I was thinking to don't consider. So how am I gonna disconsider what are already computed in the previous iteration? Okay. I was just getting a hard time to figure out this because you told me okay, you're using a backtracking, okay, but if it's a valid path. So I was wondering about this. So maybe if I try to go in this direction, maybe I'm not considering this other scenario. So I was kind of confusing that way.
Okay,
yeah.
Here's the problem with what we just said. It's oh, let me try this, let me try that. It's kind of the magic bullet symptom again. So let's logically consider this, and I'm not gonna spend too much time on it, but
all right.
But because I want to show you something else. So let's say I'm at this point, and if it were me, I do a traversal, keep track of the longest sum found. If at some node it is smaller than what I've found, don't consider it. Fine, but the thing is that fundamentally, I need to try every single path. Like you said before, the dead-ass simple solution was to try every single path, right? Even though it might not be efficient, it's going to get me an answer, right? So, I keep track of the longest sum found, and so the way I would do this is, okay, why am I stuck? I'm stuck because I need to figure out some way of, first, doing the traversal to keep the longest sum found. So my traversal, in a very naive solution, this is the naive solution, do a traversal would just mean iterate. So let's say I had let's assume that I have a doubly linked tree, right? Then just for every node, try every single path starting from that node. And so that would be equal to your breadth first search in a graph. That would essentially get me that every single path, right? Because once I generate breadth first search, then I can just run through each and every single what's it called sum. So then once I do that, then I'll just be oh, okay, then for every, what's it called, combination of nodes found, then I will run through the sum, run through the nodes, sum them up, and then take the largest sum that I have found. So really, it's more like a misdirection because you didn't understand what you fundamentally assumed. So you say do a traversal. The first thing is, how does this traversal work? That was
planning to do a depth first search, just a normal depth first search.
Okay.
From the roots, from the -10. I didn't think about starting a new traversal in every node. I think, I haven't put this idea
here. That's also a little bit of the problem because like you said, you already said trying every single possible node. So let's say I did a depth first search with -10, right? You could do a depth first search with every single node. You would have to do a depth first search with every single node. Now this could be valid, right? So let's say I did 9 and I did depth first search with 9, right? 10 and -9. I try this, and then you go 10, 9, 90, right?
Okay.
And so and blah 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 10, 9, 1, right? But that only covers the left side, because now I need to cover the right side as well. So then I go -10, 20, 15, 10, 27. But those are only one leg of the possible path, because and all I did here was really write out what that depth first search looked like. I just took your idea and ran with it, and and so this is not a problem with preconditions. This is a problem with what is the logical conclusion of my idea. Let me actually try my idea out. Use a depth first search. All I did was execute a depth first search to show you whether or not this idea would work, and then if you had done that, you would have realized the shortcoming of it. It's the next step is I have an idea. Let me see how it looks. Does that make sense?
Yeah.
Yeah, I think the problem was here.
Right.
I try like to use this concept of a depth first search and like try to create like some magic bullet, as you said, to try to remember what I already like traversed, and like try to come up with like all the sums. But like it's not like I haven't tried like exhaustively as you showed me now.
It's not so much exhaustive as it's like you have an idea, why not fucking try it?
Yeah.
And as you said, like you didn't try the idea. You just said, "Oh, I think it's gonna work," and then you just kind of moved on and fucked off. It's like, well, how do then when you come up with this idea of, oh, well, I have the longest sum, and so you have these disjointed ideas that you have no idea what they look like. You say, "Hey, I'm gonna do a depth first search, and then I'm gonna keep track of this sum somehow," but then it's just like there's no bridge in between. You don't even know how that depth first search will actually look and behave, and that is what's causing this fuck up for you. So, with that out of the way, I want to actually show you how I would solve this problem if I had never seen it before, and I want you to really pay attention to how I logically break this down. So, because I think this is going to be very helpful for you. So let's start over. Let's start off with if I was in your position. And holy fuck, who the fuck is messaging on Discord? All right, it doesn't matter. So let's start with given a non-binary tree, find the maximum path sum, right? And I'm at the bottom of the dock. So the first thing is to always find like some dead ass simple solution. Holy shit! Wait, let me see if I can mute people on Discord. Shit, that's actually kind of annoying.
Yeah, it is.
Yeah, give me a sec. Sorry about this.
No problems.
Okay, there we go. So the dead ass simple solution is that will guarantee me that I have a solution that doesn't work, that is not necessarily optimal, right? I would say generate every single possible path of nodes, and then for every single possible path of nodes, as if it was a graph, and then for every single possible path, calculate the sum, and then keep the maximum sum. This would literally be a guaranteed solution to work. Would you agree?
Totally agree.
Okay, great.
Totally agree.
Okay, perfect. And so let me mute my server for a second for 8 hours. Fuck, motherfuckers. Anyway, so this would work. But the thing is that I need to. Okay, so the question now is, how am I generating this possible path, all the possible path of nodes, right? So this is the answer I need to ask first. How am I doing this? So I could do this many different ways. I could try, like you said, I could try a depth first search of every single every single possible possible node. But what I'm going to do is actually, I would argue, just do a a breadth first search as well of every single node, and then excuse me, and then just do some permutation with that. And so it would just look something like, let's say I had a 2 1 3, right? So let's say I did 1 2 3, right? I start off with 1. I get 2 1 3, right?
Okay, right.
Okay, and so I try 2 1 and then 1 3. It would just be like for every single path, I would just literally take the first element, then the second, the next 2 elements, and the next 3 elements so far. So it's just gonna be 1 2 3 4 path. So this is basically the way to do it. Now this is obviously very inefficient. I mean, in theory, you guys do DFS, but I'm glossing over these details. But you understand that we're gonna ask ourselves, what is inefficient about this? The reason this is inefficient is because we are trying the exact same numbers over and over and over again. So for instance, in this case, I'm trying the number 2, right? Then I'm trying number 2 1. Then I'm trying number 2 1 3. This is pretty inefficient.
All possible.
Yeah. So basically, for me, it's just oh fuck, this is so inefficient because I'm retrying the path, right? And retrying the path over and over and over again, recomputing. The other one is that I am basically generating a bunch of other paths as well. And so this would also generating a lot of other paths. So these are the two areas I want to try and, try and go ahead and try to fix. So the first thing here would be like, okay, I'm retrying all these paths over and over again. Is there a way that I can just simply, traverse this path while, being able to actually come up with a sum? So in reality, when I look at this, I'm thinking, okay, well, instead of trying 2, 1, 3, I can just try some combination of 2, 1, and then 1, 3, and then 2, 1, 3. So, for instance, this 2, 1, and then 1, 3 would, if I combine both of them, those would be equal to 2, 1, 3. Do you understand this? Do you understand? Because in theory, I don't need to try a 2, 1, and 1, 3, and then 2, 1, 3. In theory, I can just composite these, but I'd be double counting the middle one, but you get the idea, right?
Yeah.
In theory,
You're
this
just
could
like
work.
avoiding one recomputing.
Exactly. I'm trying to avoid the recomputation. So all I'm doing right now is just simply optimizing on some simple little example that I have. Like, if I could figure out a way to combine this leg 2, 1 and this leg 1, 3, and that would also be able to test the path 2, 1, 3. So, what do I need to do in order to accomplish this? Because there are some shortcomings to this, right off the bat.
Okay.
Like, for instance, what if there's shit underneath 2 and shit underneath 3, right?
Yes.
Well, I want to be able to say, let's say like this is X and Y, right? I need to bring up a leg. I need to bring up a path such that, let's say like X, 2 plus X is a path, and then 3 plus Y is a path that I want to use. And X and Y could be on either side. This is just an example. The thing is that if I want to maintain this idea of a path, then I need to go through X, 2, 1, 3, and Y, possibly. Or I can go through X, 2, 1, 3. You understand? Now you're understanding, like, oh, well, what if there's shit underneath here? Well, okay, the shit underneath that I'm going to pass up is going to be a single path, right?
Yes.
It's only going to go through, like, one of the legs. It's not going to contain Z at all, because that would be Z2, X1. That doesn't make sense. So I know at the very least, I'm going to pass up a path from, from one of the legs. So, pass up a path from one of the legs. So, I know that I'm going to need to pass that up, that run through the child node, or whatever, or should I say this node. So,
Okay, I understand your idea.
so you understand the idea, right? What I'm going to do is I'm going to composite at this answer 1. I'm going to composite either 2x2, x21, or x2, 3, y, blah, blah, blah. It goes back to this whole combination idea, right? The only difference is that I'm actually going to be reusing that leg and then bringing it up. And all I'm and I'm starting to get closer to the answer because all I'm doing is just dodging the recomputation.
Yeah.
So
I understand the idea.
Yeah. So all I'm doing is just like taking the simple solution and then going over the night and then like saying, hey, what's wrong with it? Why am I generating all these fucking paths? Can I just, do this a little bit more efficiently? And then I'm just like trying to optimize on that. And so really, now that I've come up with the idea of passing these legs up, the next question is, well, how do I know that x2 is not going to be bigger or smaller? Is not going to be bigger than, let's say, that if this was -1, right? How do I retain this x plus 2? And keep in mind, x can have a bunch of shit underneath it as well, right?
Yeah.
So, so then I would, like you said, I would say, okay, let's keep a global maximum because when I'm at 2, I'm going to keep track of what, I'm going to do this computation, right? I'm going to try computing whether or not I need to add, let's put the z back in. I need the z plus 2 plus x and whatever fuck comes along with that, or z plus 2, or, x. I'm going to evaluate all this shit. So, let's take this leg here because I've been doing this. So, let's say the path with z plus 2, the path with x plus 2, or 2, or a path with z plus 2 plus path with x. These are all my candidates for like the maximum, right? So global max. I could try any
all
of
your
combinations.
possibilities. Yeah.
Or 2 alone, or path, right? So this is like at each single node, I'm going to do this evaluation. But remember what I said before. We are going to pass up a path from one of the legs that runs through the node. So this could be like path with z plus 2, path with x plus 2, or just 2 alone, because x and z, the path with z and path with x could be negative numbers, right?
Yes.
So I'm going to pass this up. So you see here, like, our problem is actually starting to take form.
Yes.
Now you understand,
It's going
like,
from the basic. Yeah. And yeah.
Yeah, no. What I'm saying here is that all I'm doing here is just taking these basic ideas of like, hey, well, let me try to create a path by combining 2 legs. And all I did, and the only reason I got to that idea was because, hey, well, I am recomputing all these different paths over and over again. Why don't I just reuse it?
Yes.
And you see how, like, it was very easy for me to, like, just walk through the problem. Now, of course, this takes a long time for me, but it's a logical way for the interviewer to follow exactly what I'm doing. And that in itself is communication. And he can see here, yeah, I'm getting on the right path. And, eventually, I can see how this is going to do my recursion. Because this path with z is just a recursive call, right? This path with x is just a recursive call. Because fundamentally, once I get to 1, 1 is just going to be if I calculate this, its global max at 1 is just going to be a calculation of path with 2 plus 1, path with 3 plus 1, or 1 alone, or path with 2 plus 1 plus path with 3. You see how this just becomes a recursive problem after that.
Yeah, for sure. I see this.
And so what I want you to get out of this problem is I want you to really just make sure that you take the naive solution that works, because there's a part of it that works that you want to keep, right? And then you want to be able to identify what is inefficient about it. And then once you do that, then you can iterate over and over and over again. And this is going to help you get rid of your magic bullet problem, because what's blocking you, what's preventing you from making progress, is the fact that you're not trying the idea.
Okay.
And this is, and what I want you to do here, and I really want you to understand this, is all I did was go for the naive solution and just fucking try it.
I have a question.
Yes.
I have a question. That sometimes I get worried about this. About one thing. For sure, I did wrong, like trying to come with this magic bullet. But for example, okay, try the possibilities. But I sometimes get worried about like try very hard in just one way, and I had the conclusion. This little detail is not letting me advance on the question. I maybe should go in the other path, So sometimes I get this problem. I just how you my question is, I haven't asked my question. You start to make sense, or it's basically experience, right, to tell you that you're going the right path, right? Because
yes
I
and no.
sometimes get this problem.
This is actually a problem in engineering in general, and what you're touching on is how do I know I'm on the right path, and am I going too deep in the wrong direction? And usually the interviewer will tell you that. They're like, oh, well, you're going in the wrong path. I don't think this is going to work because X, Y, Z, And for me, what I was trying to do was say, hey, I want you to keep in mind this case, you're not necessarily on the wrong path, but you do have some issues that you might run into. And I get the temptation to give up, and I get that. But then you notice here, I was afraid of I didn't complete this idea of generating all the possible paths of nodes. I didn't flesh out this idea. Am I doing the right way or wrong way? But I knew that at the very least, this naive solution had something to it, right? There's a reason why this works.
Yeah.
And that's
it's inefficient, but works. Yeah.
Exactly. And so as long as you try to improve that, then you're going to eventually get something that is pretty optimal. It might not be some crazy optimal one, because usually those are competitive programming problems that require some fucking math PhD. And most of these interview problems are not like that at all. Most of them are just hey, you can just get the answer to it, and all you have to do is just, strip it out, make it more efficient over and over again, and eventually you'll get there. You might be a little bit slow at it, but as long as you can keep improving the efficiency of it over and over again, the interviewer sees, hey, you're on the right path. You might not have seen this problem before, but we give you hella points for being able to work through it continuously and not get stuck. So, going back to your question about how do I know I'm on the right path? Well, generally the interviewer will tell you, and as long as you're just trying to make this right, then you're going to be fine. As long as you try to, stick, you have something that works, all you do is just strip out the incorrect stuff, you're going to be fine.
Okay, I got it.
So,
Right.
so, any other questions so far?
No, I think it's okay.
All right, cool.
I acknowledge my problem here.
It's fine. Yeah, so I want to do another problem with you. And this time I really want you to focus on like this idea of being able to like start with the naive solution and being patient with it. Because I think you're thinking about like the timer, you think about, oh, am I communicating enough? Am I not communicating enough? Et cetera, et cetera. I really want you to like just try this out. I want you to try being able to start with a naive solution and being patient with it.
Okay.
Sorry.
I'll try.
Okay, let me get another problem for you. Okay. Which one's a good one to do? This one's a little bit similar, but I think it's similar enough that it might actually be worth doing. Okay, yeah, this one's similar enough. That's fine. Huh? Yeah, I'm just picking the problem. Okay, this is gonna be pretty similar, but again, I want the whole point here. It doesn't matter if like, oh, it's so easy or whatever, and I've shown you it. I really want. I don't want you to like try this magic bullshit just because like I told you how to evaluate the answer. I want you to really understand the logic behind going through the problem. So, no rush. Just take your time. Go through step by step. Start with the naive solution, and then just go for it. Okay.
Okay.
So I'm going to find a root to leaf with a specified sum. So I gave you a sum of 8, right?
Right.
And so here, if we took the path 1, 3, 4, we could arrive at our sum of 8, right? Because you add 1 plus 3 plus 4, right? But then if I gave you a sum of, let's say, 38, there are two different paths that you could give me. You could give me 10 plus 28 or 10 plus 13 plus 15. So.
Okay. Okay.
This is going to be a little bit easier, I realize, but yeah. I really want you to not just like throw random shit at it just because you can do it, so.
Okay. Well, starting from the most naive solution for this, like my first thoughts about this, once again, I can have like, let's say this target sum here, all right, and do some traversal here since it's a path from the root, from the root to the leaf, all right. It means that it's just one path. I can basically exhaustively like try all of my paths. So for example, I go like one branch, right? Is that correct to say one branch here, like from 10, 13, 14, and then 20. And check. Maybe I can keep track of if this branch here is like being the same as the sum that was given to me, and check. Okay, is this valid or not? If yes, so if it's the same number, I'll consider this as an answer.
Okay.
I'll just gonna gather this.
Okay.
And then but for example, if 10, 13 is not the case, but 10, 13, 14, 22 is another possible way. I'm gonna make use of the previous part of my other result. So I'm gonna just go back to this. I'm gonna have 10, 13, 14, and then I'm gonna add the 22 and check if it's a valid. So basically, so I don't lose my line of thought.
That's fine.
So check the paths from root to leaf, that make the sum. So yeah, that make the sum. Okay, but while checking the paths,
Mm-hmm.
I need to. So for example, mm, okay, so there's a problem with this.
Okay.
If I am traversing here and I get like a result that is greater than what I expect,
Mm-hmm.
for example, mm, yeah, if there's like greater than I expect, I should like think, I should maybe think if there's a problem with this. So for
Why?
example, uh, no, let me see. Because from this way down, there's nothing more I can do.
Well, what?
So
Okay, okay. What assumption are you making about the tree?
uh, I'm making the assumption that okay, I should ask this. The nodes are like positive nodes.
They can be
Okay,
positive or
like
negative.
I'll give them positive and negatives.
Yes, and so you
Uh,
understand like what you just said there was an assumption that every single node in the tree was positive, and I think this is because you assume that the examples I'm giving you are representative of everything you might encounter. No,
yeah,
this is
I
just
didn't try out my examples. Yeah,
yeah.
you're right.
I want you to try
So
out, try to
So
understand
for
this.
example,
Mhm.
if I got like example like -5,
Mhm.
and I have a tree like this one, I'm not gonna like put the branches, but anyways, I'm gonna structure like a tree, and I have a -6 here, so this is gonna be a possible path, right?
Mhm.
And then I have here like 9,
Mhm.
but here I have something like that adds up to like this -5. It's to -5, and
Mhm.
then here it's not valid. So what I'm gonna do is to go from 1, okay, to -6. So like, why I'm doing this, I'm gonna compute like 1 plus -6. It's gonna be like, how much? I'm not that good. I'm not that good in math today, so or it's because I'm kind of nervous. um. Okay, it's sorry, I just like got blanked.
That's fine.
So yeah, it's gonna be -5. I did this account. I don't know. I just got a little bit nervous. Yeah. Okay, so it's gonna be -5. So what I'm gonna do? Yeah, this result is equal to this sum. So I'll consider this. So this is gonna be a possible answer.
Okay.
So let's
I
say
mean, you could just
that this.
yeah. Go ahead.
Yeah, this is gonna be a possible answer.
But you want? I want you to keep. I want you to return the path. So.
Oh yeah, oh yeah. But while you're traversing the path, like for example, I'm in the route, okay, I'm gonna like temporary store and like maybe something here, and -6.
Okay, okay, okay. I think we're getting
And
too far off. Let's start over. Wipe the slate clean. I think
okay, okay,
you're
okay,
trying to just like, oh, well, but this and that. I want you to really focus on the logic. Let's start with declaring exactly what your naive solution is. Let's
Okay,
start
okay.
there. What exactly is
sorry.
your naive solution?
Oh sorry. Uh, try all paths, from root to leaf, as I write it like there.
Okay.
Root to leaf, and storing like oh sorry, store the nodes visited. All right, store the nodes visited, and visited, and whenever I'm in a leaf with like the target sum, consider, so I'm going to consider the path as a result, as one of the results, as one.
Here's the
of
problem. Okay, so what is the problem
result.
with this already? Why is this? Why does this not work?
Why does not work?
Wait, are you saying that this is all that is it?
What?
Are you
No,
saying
no,
that-
it's not. No,
Okay.
no, 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 it's not all.
Okay.
And what? I'm not finished. Like my
Okay,
my
go ahead.
like
Go ahead.
my naive solution.
Okay.
And then go back and like try other paths. So gonna go back in the backtracking.
Okay.
And try the other branches. Go.
Sure.
and try the other branches.
Mm-hmm.
But while going the backtracking, I should like pop
Sure.
like that leaf.
Mm-hmm.
So pop the leaf or node
Okay.
value. Yeah. And yeah, that's it. And whenever I reached a branch, so no, sorry, whenever I reach a leaf that I know that is a leaf because have no children's, like I know that is a leaf, so I will consider like my sum until this leaf if it's equal to my target sum, and
Okay.
if it is, I'm gonna like store like the results that I've been gathering, collecting while traversing, and that's it. And then when I'll
Wait,
go
wait, 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 wait,
like
wait. Slow down, slow down. Stop, stop. You are
uh
adding more to what you just wrote. You keep in
uh
mind, you wrote consider the path as one of the results. Now you're adding on, oh, well, I need to keep track of the sum and calculate the sum as I went for it. Do you understand why this is a problem?
um no, you were asking if why is a problem like to keep a sum
No,
of
what
the
I'm asking is why do you think it's a problem to add more than what you've already written like this?
because it's like it's not efficient.
No, you haven't
It's like
justified it. You haven't justified what you're doing here. So first of all, let's slow down. Let's say that is this what all you want to write, or is this more that you want to write?
no, it's basically that is the whole idea.
Okay,
Yeah.
let's try this out on a single example, right? Let's give you the
Okay.
first example that I gave you.
Yeah.
So
Okay.
we're gonna
I'm
get
try
all the
it.
paths from root to leaf, right? And we're gonna store all the
Yeah.
nodes visited, and then whenever we get hit the leaf with the target sum, we'll consider that path as one of the results, right? So
Yes,
I'm gonna go
basically.
through 1, 20. Leaf doesn't match, right? I go 1, 3, 4, 6. Not a match. 1, 3, 4, 7. Not a match. 1, 3, 15, 8. Not a match. 1, 3, 15, 9. Not a match. Does your algorithm work?
Um. Oh, it's not gonna be any answer for this.
Right.
And my algorithm is not gonna store nothing in the result. So, yeah. Sorry. Oh yeah. I understand your point. It's not gonna work. Yeah, it's not gonna work.
Yeah.
Um.
So is
Yeah,
how
I
can you say that?
understand the problem here.
Yeah. So how can you say your naive solution works when you haven't even tested it? And then why are you adding more shit onto it when you haven't even tested the base solution?
Yeah, yeah, you're right. So, yeah, I got the point.
Okay.
So, uh, a route to leave. Okay, so I'm just wondering why is like 1, 3, and 4 is considered a path, even though like 4 is not a leaf.
Okay.
So I'm just wondering why is this considered a path? So, 10. Okay, yeah, I have a question.
Okay. Yes.
I have a question for you. Uh, a route to a leaf with okay, a route to a leaf is only like the direction, right?
Correct.
It's not gonna be considered that in the leaf I must have the sum that was given to me, right?
Correct. The path the
Okay.
solution does not necessarily contain a leaf. It's
Yeah.
just the direction. That's correct.
Okay, okay, that's correct. Okay. Okay. So, like, modifying my naive solution here is try the paths. Try the paths going from root to leaf. So not necessarily into the leaf. And store the nodes visited. Okay, that's correct. That can be a possible answer. And yeah, this is bullshit. So okay. Uh, Whenever I have a sum, like have a keep track of like the current sum. Keep track of the current sum. Whenever like the this current sum hits the desired value, uh, consider as a path. As a path. Consider as a valid path. And that's it. And then don't advance because There's nothing. Yeah, no, there's a problem here. Let me just try one thing here.
Okay.
Okay, so imagine that in this first example here, instead of 6 was like -8.
Mm-hmm.
Okay. It's the same thing. So I'm gonna traverse 1, 3, 4. It's already like a path that I desire.
Okay.
So I stop here. I stop here. I'm just wondering if, like, for example, if I can make another path by summing up like another values here. So for example, no, I'm just like overthinking here.
Okay.
Okay, let me go back to the original. Anyways, yeah, I think that's it. I can consider like this is one of my base cases. So why are you traversing? Let me see if there's more thing I can like optimize here, like following your what you said about the last question.
Okay, let's put a pause right there. You came up with some new idea. You think this is gonna work. What's the next step?
Test it.
Bingo. Go test it for me.
Okay.
You got to have the 1, 3, 4. I want you to walk through walk through a sample, and make sure it works. Like literally, just go through step by step.
Okay, no problem. I'm gonna put like the same here.
I want you to come up with like your own example as well. But yeah, you can do this one. That's fine.
Okay. So for example, and the target is the sum, right?
Okay. Yeah. Go ahead.
8.
Mm-hmm.
Okay. Just a moment, so I can like go step by step. Okay. First thing, I'll try like 1. I'm gonna, let's say I'm gonna be tracking like 1 and 20.
Yep.
All right. So this is like more than 8. It's not gonna be considered. So I'm gonna move like down.
Hold up.
So I'm gonna go back.
Hold up.
Right.
Hold up. Remember what you said before. You said more than 20, and you also said that you also asked if we're dealing with all positive numbers.
Yeah.
So why'd you say more? Why are you going to stop just because it's more?
Yeah. No. Yeah. Oh, yeah.
Okay. So, no. Yeah, that's the point.
I would highly recommend you write that detail down. By the way.
Okay.
And just making sure that that your assumptions.
Okay.
Because I see that you kind of forgot about it. So go ahead.
Yeah. Keep track of the current value. Whenever the current value hit the desired, consider as a valid path. All right. Okay.
Sure.
If it's different, okay, yeah, because, for example, I can have a path here. Like I can have another value that can be 8. So until it's not until it's not the value keep traversing. We can find a possible path for this. So for example, if I found here like 1 plus 20, it's gonna be 21, and then I do like minus 12, it's gonna be 8. So if I have like a value here that is minus 12, it's gonna be a valid path. So 120, and yeah, because it's gonna be exactly the same value. So I'm gonna go up to my example. So I'm gonna do as like you showed one time.
Yeah.
So I'm gonna go in the 20, and then I'm gonna go in the minus 12. So here I'm gonna check. Okay, here it's gonna be 1, and here it's gonna be 21.
Okay.
And here it's gonna be 8. Okay. Oops. It's correct. Is the sum that we're trying to find. So I would consider like this whole stack trace, but I'm gonna be like storing this. So this is it's a valid path. So 1, 20, and then minus 12.
Okay.
It's a valid.
Sure.
Then I'm gonna go like down the recursion stack, and I'll try like to traverse to the right side. There's nothing. And then going back to the root here, and going down, like I'm gonna have like let's say as a buffer, right? So it's gonna buffer my solutions here. I'm gonna have 1 in my buffer, my possible solution. Let's call it like this: 1, 3, and I'm gonna be in the 3. All right, that the sum is gonna be equals to 4, and I'm gonna try in the left. Is this equal to my desired? No, so I'll traverse to the left. So it's 4. I'm gonna have 4 here, and I'm gonna be in the 4 here. But this is gonna be like 8, so I can consider this as a path. So as a valid path.
Okay.
But I'm not gonna stop here because, as you said, like it's not like anything of it's greater or not. So it's just another possible way. So I'm gonna keep traversing. So like 6, I'm gonna go in the recursion stack here, 6, and add it up 6. Oh, sorry. Here it's gonna be 12. Okay.
Well,
No, it's gonna be 10. Yeah.
are you sure?
And
Are you sure?
oh no, yeah, 8. Yeah, is okay.
Wait, are you sure?
No, it's because I'm adding to like.
Yeah, so it's
this.
8 plus
Okay.
6.
No, sorry. Yeah, I was just like looking to the 4. It's gonna be 15. No, it's gonna be 14.
Are you okay, dude?
No, sorry.
Are you
9,
okay,
10,
dude?
11, 12. Man, I'm just nervous. I'm not in my
Okay, okay.
native
Take
language.
take 10 seconds. Calm down. 10 seconds, okay? Let's take a breather.
Okay. Sorry about that.
Three deep breaths. No need to rush this. Because if you can't
What?
do simple addition, I don't know if I can help you.
No, sorry. It's just a matter of like I'm not in my native language. Yeah,
It's
sorry
okay.
about
It's okay. I totally understand, man. I'm not trying to poke fun of this. It was just like, yeah, just take a deep breath, calm down. It's
you're
it's
making
okay.
me
It's just
sweat.
practice.
Yeah, yeah, it's because like we're like so used to like do sums and like math problems like in our like native languages like
I understand,
sometimes,
man. All right. 5 seconds. 1, 2, 3, 4, 5.
Okay.
All right.
Okay.
All right, you feel a little better now?
totally fine.
Feel better now? A little
Totally
bit?
better.
Okay.
Totally better.
Okay.
Low vibe.
All right.
Yeah,
Low vibe. Let's chill out, man. All right. Let's keep going.
14. Okay, it's not the desired sum.
Yes.
Okay. So there's nothing I can do here, nothing more to traverse. Then I'm gonna go back here and then try my other path. That now I'm not gonna mess it up with the math, right?
Okay.
That is 15. All right. And then yeah, nothing like this is like any valid path, right? And then I'm gonna go back here and like in the recursion stack, I'm in the 4, and then I'm in the 3, and then I'll try out the 15. Okay. So
I'm gonna put a stop
You
here
see,
because I think you understand. I think you
I
understand
know
how
how
to do
to
it.
do math.
Yep.
All right,
Don't
yeah.
worry. I understand. I'm gonna say
And that's
you have a
it.
good idea of how to do it. I think you can go ahead and write the code if you want to go and solve the problem.
Okay. So
I think you have a good idea of how to do it.
So I'm gonna have my function here called sum path sum. Let's call it like this. Path sum. And I'm gonna receive in like a root, okay, and that's it. And like a sum, like a target. Okay, like a sum, like this. What I'm gonna do is have this result, okay, where I'm gonna be given my result, and like a temp that's gonna hold like a temporary result while I'm traversing. And I'm gonna call this function this DFS here, passing this root, and let me check here. And my current sum that here is gonna be equal to the sum, and yeah, that's it. And yeah, no, actually I need to also pass the temp. Yeah, also the temp. Yeah, and in the end, I'm gonna return like this result. Okay, so I'm gonna do my function in here. So this DFS, which I'm gonna receive, like here, I'm gonna call a node because necessarily is not gonna be a root, and like a current sum. Okay, and yeah, here this sum is gonna be 0. I just messed it up with this, and yeah, here is gonna be like the no, I don't need to pass this temp because it's already like globally there. And yeah, that's it. So defining the base case here is that it's if it's valid. So a valid is like if the sum is equal to my current sum, as I mentioned before. Okay, so if the current sum is equal to the sum, what I'm gonna do is like inside my global solution, I will append like a copy of my res. No, actually, sorry, my temp, and then pass in the copy of this. Yeah, and here I'm gonna try out like the left and the right subtree. So the way I'm gonna do this is like I'm gonna run the DFS for my node dot left. Oh, actually, I need to consider like a base case is not valid. So I'm gonna pass my node dot left, and my current sum is gonna be equal to the node, the value of this node. Okay, and I'm gonna do the same for the right. Yeah. And yeah, there's another base case. So if it's not valid, so if not node, there's nothing I can do here. So if not node, I just have to return because there's nothing I can do.
Okay.
And yeah, that's it.
Okay. Is this the
Okay.
is this it?
Let me just check the correctness
Mm-hmm.
of this. Yeah, I can run a test if
Yeah,
you
sure.
want.
Go ahead, run the test.
Okay.
And I'll be very interested to see how you test this.
Okay, let's see. Yeah, I can catch some bugs while testing. Okay, so entering here. Oh, actually, there's a thing I was thinking while coding. I need to like pop. When I go back in my like going up in my nodes, I need to pop like a value. I
Sure.
just need to consider. Let me just check here. So I'm returning. Okay, if my current sin is equal to my son, I will pen a copy. Yeah, and return it. No, yeah. Yeah. Yeah, there's must to be like it can have like other possible paths other than just the one that I found like in the same branch. So I'm gonna try left and right. Um, yeah, I'm just wondering. Uh, mm, so yeah, yeah, inside my temp, I need to like add the current value.
Okay.
So yeah, the whole purpose of this is like to put the values here. So I'm gonna be adding the node value here,
Mm-hmm.
and yeah, that's it. In the end, I'm gonna be popping this
Sure.
like uh yeah. I'm
Okay.
just
Are
gonna
you sure this
pop.
works? Let me ask you that.
Uh, like based on what I did here, I think that is the implementation. I should have like
You want to try
do
running through
some.
it? You want to try running through it?
Yeah, for sure.
Yeah.
So going like okay, starting both arrays like empty, and then I'm gonna go in my root. Okay, my current sum, it's gonna be equal to 0. Yeah, let me. I'm gonna be doing like just a moment.
Mm-hmm.
Okay, here I am. Okay, in the first node, and my current sum, yeah, doing the same thing all over. So I'm gonna be, it's gonna be 0. It's not the same. And then no, actually, just a moment. Yeah, actually, what can I do here? No, that doesn't make any difference here. Yeah. Sorry, I was like kind of nervous. Sorry about that.
Mm-hmm.
Okay, and I'm gonna be in the 20. Actually, the value that was passed here was 0, and then like whenever I'll go to the 20 branch, it's gonna be like 1, all right?
Mm-hmm.
And then I'm gonna try for both sides, like, but it's gonna be null, so it's not gonna work. So let's exclude this value here.
Okay.
I'm gonna try to both sides gonna be null as I repeated. Actually, it's not gonna be no. It's not gonna be equal to the current sum, so it's not a valid path.
Okay.
Uh,
Keep in mind the
and
path
then
you're testing is you're the sum right now is 1 when you've entered 20. Is that what you want?
no, it should be 21 actually.
Okay, so
Yeah.
then where'd you mess up?
I should have like made the sum before.
Okay.
Like considering, yeah, I should have like made this sum somewhere around here, like so I can consider like this is a valid path. So yeah, I should do something like this here. I'm just gonna exclude this for better
Sure.
readability.
Okay.
So my current sum is gonna be like this.
Sure.
And here, yeah, I'm gonna pass like just the current sum, so don't
Okay.
sum again.
Okay.
Yeah, I think it's better.
Okay. I'm gonna stop you here because just for the sake of time. Your answer I think
Yeah,
is
yeah,
pretty
okay.
much complete.
No problem.
But I want to review like how you actually approach this problem. So let me ask you, how did you feel about doing this problem? Feel like you would have done better or worse? What was your feeling?
I would say, like compared to the other problem, I think my point of view, I did best because I think more in the cases, like in the case that it can be wrong, like giving your heads up about okay, it doesn't necessarily needs to be greater, it just need to match exactly some. So I was more carefully about like think about this detail that can and cannot work. But I would say yes, and I would consider this problem like more easier. I was just more nervous. I was just kind of nervous, to be honest. But in the last problem, I acknowledge like what I have like to go more deep and like try the possibilities. Here was like much more easier for me. I had to confess.
Yeah, right now this problem was just an exercise in being able to think cleanly. It's not so much whether or not you get the right answer. It's about the process you take to do it. And I think there was a few things that I saw that were a little bit interesting. For one, when you came up with a naive solution, you had trouble testing it, and they keep track of like this by itself is correct. But what I found interesting was that you essentially tried to go a naive solution, but then you patched your way to an optimal one without really understanding the inefficiencies and stuff. So let's go back to like what you wrote before. So you said try all paths going from root to leaf, store the nodes visited, keep track of the current. You kind of like patched your way into it. Instead, I think because before what you said was something like try all the paths from root to leaf.
Yeah, I said this.
Yeah,
like,
you said
in the
that, but then
beginning.
it's just like you kind of ended up just like patching your way through because I assume that you kind of made the association with a depth first search, which, you know, it kind of makes sense. But the thing is that we're really trying to eliminate that kind of magic bullet thinking. What I was hoping that you would do is you would be able to tell me that, hey, because, you know, we're generating all these paths, like was it like from 120, 13, 134, 1346, etc., we're inefficient in that we're trying multiple paths that overlap. This was my hope. And so
I should be very clear about this, right?
Sorry, go ahead.
I should have been very clear about this, right? And
Correct.
I was not. Okay.
Correct. It's because you basically just ended up, like I said, you just patched your way into a magic bullet solution. It's like, oh yeah, this works. Because this is how I fix it, like why it doesn't work. But what we're really after is trying to go from something that works to something that works even better. And so I want you to keep that little mistake in mind. It's a little bit concerning, but it's fine, I guess, for now. But then you always ran into this issue of like, oh yeah, well, all the numbers are positive. And even when I told you not all the numbers are positive, and then you still kind of went with, oh, all the numbers are positive. I assume that's a consequence of you being nervous, but I would also say make sure you write it down. I want you to be a little bit more detail oriented when you go through this stuff.
Okay.
One other thing is that when you walk through the problem, I liked it. I would say name your variables a little bit better. Because like
Okay.
we're saying 3 = 4 equals. I personally, when I do it, I always like keep track of the variable names, and then I always keep track of like their values as well. So I store a copy of them in order to recognize whether or not they're deep copies or not. And I know this might seem small, but it helps in a really big way. Especially when you went over here. If you had just said, "Hey, this is like sum," I think you avoid. I think like something like this. I think you avoid this mistake.
Yeah.
So I want you to be a little bit
Yeah.
more meticulous about the details when you go in and actually solve these problems. So you were
Okay.
correct in identifying the backtracking. I think most people would. I think most people would be doing it a little bit faster, but this was the big mistake. It's because you weren't like as detail oriented about like what the value of each variable was, how you tested it, and running through it, and just being able to do that is the big difference between making a mistake later on like this and not making a mistake. Does that make sense?
Totally makes sense.
Yeah.
Yep.
So I would say the problems kind of started with the naive solution a little bit, where you're just like you didn't actually try walking through the proposed solution, and then you ended up making a jump to like, oh yeah, well this doesn't work. Let me just patch it with this idea. I want you to be more complete with your idea. I want you to try driving your idea to completion before you decide to pivot. Because well, even though I kind of do this as well in my videos, the fact of the matter is that I can drive an idea to completion.
Yes.
And that's the difference. And you know,
Okay.
it's implicit, but it makes a very big difference whether or not you can solve problems or not. So I'm
Okay.
do you have any questions so far?
Yes, I have two questions. The first one is, would you consider like a better like way to test, like putting out the variables like in a space like this, as you like mentioned, like write the name of the variables here, or because I've seen like people doing writing the values of the variables in the variables of the code itself. So what do you think is like better?
Personally, for me,
in
I
terms
like
of-
doing this. I like doing this better. I don't like littering my
Uh-huh.
code with comments and
Uh-huh.
like values on the side, because what if it's recursion? Then you're fucked because what your current sum is like, let's say 7. You go into recursion, now my current sum is 9, and I pop out the recursion. Wait, what was my previous sum?
Okay.
You get fucked like that. And that clutters my workspace. So I like this better, especially because a lot of these problems only require like 2 or 3 variables, so you don't need to keep track of very many.
Yeah.
Not to mention,
You're right.
this is like part of like what's called pseudocode area as well. So then all that's left here is that you have your actual code, right? And you don't have to clutter with a bunch of other shit. The whole purpose of doing this pseudocode is so that way we can think a little bit more like patterns and objectively, and not have to think in terms of code. The code just really expresses the idea.
Yeah.
So
You're right.
Yeah.
And like the other question was like, so just a conclusion. Correct me if I'm wrong, please.
Uh-huh.
So basically, when I was like trying to solve the problem, maybe be more clear and define like, okay, this is the naive solution. So I try like all the possibilities, but I'm gonna be overdoing work and like say, okay, from this we can like make it better, so we can go to a more optimal solution. And then from this point on, like keep working like with the improvements. Is like correct?
Yeah, I want you to come up with like a naive solution that works. It might not be the prettiest, but I want you to complete the idea and then say, "Hey, this is why it's not the most efficient in the world." And then you improve upon that.
Great.
Yeah.
Yes.
And so, I think that it's like kind of important, even though it might seem trivial right now, especially in the context of the problem that you just did. It's a really important idea because it would have helped you solve the first problem that we did. So,
For sure. If I like be more clear why you're
and be more
trying,
detail
like,
oriented.
because I have to be very honest.
Uh-huh.
When you are like trying like all the legs of the tree, the way you mentioned, right? I thought about this, but I didn't try, as you said. I didn't like work on like try, because I thought, maybe if this is not gonna be possible to do, I assume that would not be possible. So like based on your feedback, I should like try. Okay, maybe it's gonna be possible by doing combinations and like combining with the other leg, but I need to figure out like how to combine it with the other leg. I think that was pretty valuable for me to
Yeah.
think.
And now that you saw
Okay.
it's like, okay, now I have a reason to actually fucking try that idea.
Yeah, for sure.
Yeah. And
You're
so that's
correct.
really what I was hoping you get at. If I can make that, like, lights turn on in your head, just say, hey, let me try. It's like only just like, one little thing that's between me and a little bit more optimal solution. Why wouldn't you get over that one little hump? So,
Yes.
okay.
Yes.
So let me go ahead and bring up one more problem. This one is, I want to stick with the tree motif actually, because it's like it's along the lines of what we're doing here. But keep in mind that this idea can apply to anything. It grabs,
Okay.
arrays, but for now let's focus on the trees.
I haven't practiced trees in like 2 weeks, so it was very good to pick me like in a very kind of like not unprepared way.
That's fine. I mean, it's like at this point, either you know it or you don't, but at least you were able to recover, so it's fine.
Yeah.
Let me go ahead and let me find another problem. No, not this one. This one's not a good one to give. This one, is it this? Should I do this one? Okay. Oh yeah, we can do this one. Okay, this one's a good one. Okay. So I want you to test if a binary tree is symmetric, right? So let's say I have what's it called, a tree that looks like, I don't know, this 5, 1, 0, 1, and 5, right? This is symmetric around its axis, right? But the moment let's say I add in like our left child and right child right here, and then let's say I have a 7 here. This is no longer symmetric because around 101 it can't be mirrored. Does this make sense?
Yes.
Great.
Yes.
And
Okay,
I want you to focus on like two things. I want you to focus on coming with a naive solution and then going to an optimal one, and then I want you to focus on being very detail oriented when testing and coming up with your solution.
Okay. Okay. So I'm just gonna throw my first thought here. So to be symmetric, like just defining this, the nodes of like left and right should be the same, right? So they can be mirror, as you already mentioned.
Okay.
All right, and whenever I found like one side of the tree that does not mirror the other side, or like have some different, that does not mirror the other side, I should like flag this as a non-symmetrical tree.
Okay.
So yeah, it's totally clear for me. What is this? So basically, naive solution that I was thinking was basically maybe go through the nodes in the left portion of the tree and then the right portion of the tree, and compare if they are the same. Okay, compare if they are the same, but like iterating like simultaneously. So let's say I'm in the 5 and in the 5 in the left and the 5 in the right. So yeah. Just a minute. Yeah. And they're not gonna be the same. Just a minute. So just 1 minute. Okay, I'm back here. Okay. Sorry. Just recapping. The naive solution that I was thinking is like traverse in the left tree and the right tree. If they are not, if I found like one node that is different from the left and the right, I'm just gonna consider that is not symmetric. So
Okay.
that what I was thinking. But I have to like be concerned, like in the way that I'm gonna traverse this, because for example, if I have a 7 here, like here, it's gonna be symmetric. This tree is gonna be symmetric because it's a mirror of like the left and the right.
Okay.
Basically, yeah. So yeah, I'm just gonna write down like a big picture of this. So traverse the left and right subtrees,
Mm-hmm.
subtrees and check if they are being being the same. Whenever I found like any value that it's not the same, yeah, that is not the same. Yeah, otherwise, yeah, they're not symmetric. They are not symmetric. So that's it. Okay. And the way, and now I like just breaking down this traverse. So the traverse in the left, yeah. So yeah, I think like the big picture is this, but the traverse in the left should be like the opposite way that in the traverse of the right. So for example, going in the left tree right here, my right child that is 7 must be equal to my left child in the right subtree. So I just gonna generalize this thought here. At each level, the value on the right, on the left child of actually the right child of the left sub of the left subtree, like of the left node in the subtree, must be equal. It's gonna be equal to the it's gonna be equal to the left child in the right subtree. So I need to like do this follow this rule like vice versa for like inverted. So the right must be equal to the left. The right in the left must be equal to the left in the right.
Okay,
Like,
sure. I get it.
subtree.
I understand what you're saying, but let's put a pause here. Your solution does technically work, but what do you think would be inefficient about this? Let me ask you that.
Oh no, yeah, I think this is the optimal solution, I guess.
Okay, sure, but and
because
you're correct. You're correct. In runtime, it is the optimal solution. But I'm going to tell you there is something inefficient about this that you may not have considered. What do you think that inefficiency is?
I need to like keep track of both subtrees at the same time. So maybe
Not necessarily. It's that's not necessarily the case. How about this? Try writing the code out for this and let me know what you think.
okay. So yeah, just going to the same like structure. So is symmetric. So just gonna return a variable true or false, all right, to define if symmetric
Sure,
or not.
yes, that's fine.
Is that correct?
That's fine, yes.
Okay. So I'm gonna receive like here yeah, the root, and that's it. And this is just going to check. If not root, I'm just gonna return false. And yeah. The way I'm thinking to do this, yeah, is just do like a normal breadth first search. No, a normal like depth first search.
Okay.
So let me just think the way I'm gonna do this.
Okay.
Okay.
Well,
Okay,
instead of doing that, why don't you just follow what you've written?
Yeah. Following what I'm reading. Yeah, I'm gonna just return the value of like, let's say a helper like a helper function.
Okay.
So what I'm gonna do is like the same thing I read it here, like in the last point I did.
Okay.
So I'm gonna take the node in the left
Okay.
um, and the node in the right,
Okay.
and yeah, pass my main route to this. Okay, sorry. Yeah. Here it's named like route. So that's it. And yeah, basically that's it.
Mm-hmm.
And now let me code it up this helper function.
Sure.
Yeah. Okay, so helper, it's gonna receive like the node itself, the left, and the right. Okay, now I'm just gonna check a base case. If not, yeah, actually, it's yeah. Actually, here I'm gonna consider this. So, I'm gonna write this statement. So, if the node in the left, okay, is different than the like what I consider the right yeah actually road no root right, okay, root right, here I am, the left. So okay, actually here's first the node right is different than the right left, okay, and no, yeah, go ahead.
I was gonna say, are you sure?
Yeah, actually, okay, 5 is the right. Oh, yeah. Actually, this is the left. This is what comes in the left. No, yeah. Oh, left. Right is different than the right left, or vice versa.
Okay.
Or the left right
Okay.
is different than the right left. If any of those cases fail, like it's not a symmetric tree, so
Okay.
I'll return false.
Okay.
This is a base case to
Sure.
validate this. Okay, but let me just check one thing if I'm covering like all the possible ways.
Okay.
Okay, left, right.
I'll
So
fix this for you,
5.
but go ahead.
Okay. Left, right, and right, left. That is totally correct. Or left, right, and right, left.
Mhm.
Okay, that's correct. I should return false. And okay, now I would check. Yeah, now I'm just gonna have to move forward. So I'm gonna do I'm gonna have this helper function. Um, Let me just check one thing here. Yeah.
Okay.
No, I'm not seeing like necessarily. Yeah. I need to have like. Yeah. Let me just write down here. So
I mean, you've already written down what you wanted, right? So
check the right and left. Yeah, and left. I'll have to check the right and left because and I'll have to store this in something. I'm just wondering like okay, let me actually do a test. So for example, if I have a 8 here. Okay. This is gonna be different. So this value it's gonna be returning like a false from like the other call of this function.
Mhm.
So like the other call of this function is gonna return false. So I should consider if any of those functions are like false, I should like return false. Otherwise, I should keep returning true.
Okay.
That's what I was thinking.
Okay.
So, yeah, I'm gonna put like try A. Is like also calling this helper function, passing the node, and yeah. But yeah, here's the tricky part. I have to pass the. Okay, here I have to pass the node left. Here I have to pass the node left, and the right in the right right. So right, the right. Okay, and in the try B, I'll have to have this helper having this node, and I have to actually here pass the left, right, and the node, no, actually.
Okay, I'm gonna stop you here because we have 10 minutes left. But I wanted you to do this because I want to show you that inefficiency comes in many different forms, not just runtimes, but also in the way you write the code. Now, let me show you why I said, hey, are you sure that this is as optimal as possible? Because this right here already screams inefficient because you're doing so much indirection. Look at how hard it was for you to even come up with this statement. It was literally spent 5 minutes like, oh, is it the left or the right, left? Do I need this node? And then you're still struggling trying to come up with this. We're only like 4 lines in, and it's actually like, it's so difficult, right? Even though it's technically a very simple idea. And I would argue that it's because you have this significant number, this indirection. The right child of the left node, the left child of the right subtree, etc., etc. And then that's fine. But then the problem with writing it like this is that you end up with something like this, where you think you have to keep track of 3 nodes: the left and the right. In reality, you only need to keep track of 2. Let me explain. Let me illustrate this further. So, if I was gonna write this, I would say something like def helper node A, node B, right? And like you said, all we care about is whether or not these nodes are equal, and then the left the child and right child, right? So for 99% of the tree, right, it's going to be actually just 2 nodes that we need to compare against one another, right? So then if node A is equal to let's just say node A dot val is equal to node B dot val, then or let's say it does not equal node B dot val, then return false, right? But then I also need to keep track of whether or not if A and B are null as well, because potentially we could be passing in null. And this is something that you failed to consider here as well. So then if node A is null and node B is not null and vice versa, return false. So this will protect me and if both null, return true, because they're the same, right?
Yeah.
So in other words, I'm only going to look at these 2 nodes, whether or not it's like 5 or 7 and then after that, like you said, I need to keep track of left child and right child. So in other words, I need helper of node A dot left, node B dot right, and helper of node B dot left, node A dot right.
Yeah.
Do you see how easy this was compared to like you trying to do this indirection? The only difference of what I did was that instead of considering 3 nodes, I just said, hey, give me any 2 nodes. I'm going to assume that it's part of the traversal. I just started down here and said, hey, give me these 2 nodes, and then I'm going to compare the left child and the right child. So I'm going to recurse in using this and this. That's the difference. The difference between what I did and what you did was that you vastly overcomplicated it with this indirection. Like the right child, left subtree, blah, blah, blah. But if you just said, hey, just take a look at the nodes, and then the left child of one should be equal to the right child of the other, and vice versa. That's it. And so do you understand this idea?
Yeah, perfect. I overcomplicate it, yeah.
Correct. And the key is that you did this really weird level of indirection here. And I really want you to remember this because this is the root of so many bugs when it comes to recursion. It's just doing too much shit before you actually try to, actually go into the recursion. And try to reach into the child's child. That is like 9 times out of 10 what will kill you on these recursion problems.
Okay.
All I did was evaluate the base case and then pass in the 2 cases I want to compare against.
Okay.
So, we have like 5 minutes left. I want to review everything we talked about, and I really want, and I think these are going to be very important. First things first. I want you to be, and the problem that we did here, I want you to be able to try to drive your idea to completion. And I'm going to write this down for you. 1. Try to drive your idea. Don't look for magic bullets. Give it a shot, and if the blockers are reasonable and easy, just fix them. So this goes back to like what I showed you before about like, oh yeah, well, passing at the legs. The second one is to be able to come up with a naive solution and then optimize on that. So this is the whole legs thing and how I was able to derive the optimal solution for that first problem, where I said, oh yeah, well, I'm going to try every single possible path, and then I recognize that when I'm doing those paths, I'm just retrying the same shit over and over again, and I can just fix that. That, usually fixing those inefficiencies is the key way you go from a naive, like, suboptimal solution to a more optimal solution. Now, the third one I want you to really keep in mind is to be detail-oriented. Oriented when coming up with your pseudocode. Or running through it. So, which means run through your test cases. Try to make sure that you fully understand what happens at each step and keep track of your variables properly. So this is where you did the whole stack trace with the what's called the equals and without the sum. I would recommend that you actually keep track of what variables you're using and why. Now,
names, yeah.
Yes, keep track of the names. And then I would say the last one is that inefficiencies can come in. Inefficiencies can be everywhere, not just runtime. How easy is it to write your code? So when you look back at problems like these, I really want you to ask yourself, hey, it took me a shit long time to write this. Why? And how could I have done this better, or at least avoided this situation? And I think I am of the philosophy that it always boils down to how you set yourself up to write the code. So, in other words, if you had just actually was a little bit more clear in the pseudocode instead of just like hand waving this check right and left condition, if you didn't do like this weird indirection of right child of left node and left child of right subtree, even though the idea is correct, if you had just written it a little bit more simply like node A, node B, and said, hey, I'm going to pass in the child of one node and compare it to the child of another node, if you just condensed the idea instead of using this weird indirection, I think you would have avoided a lot of issues. And this is where simplicity is your best friend.
Yeah.
The more simple you can get your idea, and the more clear it's going to be. The more clear it's going to be, the easier it's going to be to write your code. The easier it is to write your code, the less bugs you have.
Okay.
So.
And make sure that it works.
Yeah. Okay.
Yeah, and then I'm going to add in a little thing to the second note. When you're coming up with a naive solution, I want you to logically come up with the solution. Don't patch something just because it looks wrong necessarily. Like, technically that is what we do, but in order, I want you to build this habit. I want you to build this habit of being able to drive a naive solution to completion, and then once you do that, then I want you to be able to say, hey, here's what's wrong with it. And this is going to seem like a small thing because, you know, in the actual interview, you can always stop yourself and say, hey, yeah, I know this is going to be inefficient. I don't need to drive this. But for the sake of being able to do this in your head and to do this like cleanly and logically, I want you to do this when you practice your problems. Now, I think you've seen me in a few other coaching sessions where I show like the differential between the naive solution that you come up with or like the wrong solution and then the right solution. I feel you can watch those videos on how to actually improve at problem solving, but I really want you to focus on these points. It's like you have like 10 days or something to Facebook, and I really want you to at least try and, if I don't prioritize all this, try to fix these two things first. Come up with a naive solution and optimize on it. Don't look for magic bullets. The rest of this is just like, yeah, it's nice to have. Being detail-oriented with your pseudocode is going to help you, but I want you to really, really focus on these two things first, if at all possible. Because if you can at least come up with a naive solution and code it out, then you at least have a shot at getting that internship offer. After this, it's more like, okay, now that I'm able to come up with a naive solution and optimize on it, how can I make myself faster? That's where 3 and 4 comes in. But this number 1 and 2, if you can't even get to the naive solution, you can fucking kiss your chances of getting a Facebook internship goodbye.
Okay, I'll consider this.
Yeah.
Strongly consider this.
Mhm.
Okay.
Yeah. We have like 1 minute left. Any questions?
No, I think all questions was covered. Thank you very much, Edward. Thank you very much for. I needed this.
Yeah, for
I
sure,
was
man.
not knowing where I had to improve, and now is more than clear. Yeah.
Mhm. Yeah, and I hope these exercises really helped, and I hope you learned a lot from this session. And keep me posted about how things go, and message me if you have any questions.
For sure, for sure. I'll do it.
I appreciate
Okay.
it.
Thank you very much. Bye.
All right, bye bye. Cool. Nice. Okay. So I mean, I think you learned a lot. I think hopefully you guys learned a lot too. I have a few minutes before my next client, so if you guys have any questions about like the coaching session or anything in general, or you want to ask me anything, feel free to do so. Because we're gonna bring on our next guest. He's gonna try applying for long-term coaching. And we're gonna interview him and talk to him and see if his motivations are up and up, because let me give you a little bit of a preview. So for long-term coaching, I take on only a certain select number of clients because I'm checking in 3 times a week, and this requires a lot of time outside of my work as well. And so what this really consists of is me coaching you for like a problem solving or coaching session like this, and then also running through with you through your replay analysis and running through like whether or not you're on track based on everything that we've discussed, and making sure that you're practicing everything that we have talked about in these coaching sessions. So I only take on a select number of clients for doing stuff like this. So let me go ahead and bring him on. Let me see what he does. Okay. Basically hand-holding leak code. Yeah, in a way. I am hand-holding him through leak code, but I'm also doing it in a way that's a little bit more generic. In that sense that you can apply all these different problem-solving strategies and ideas. Doesn't matter which problem you're doing. So like, for instance, trying to drive your idea to completion, don't look for magic bullets, come up with a nice solution, then optimize on it, being detail-oriented through your pseudocode while testing. All these are things that you can do on any single problem. Now, the question is whether or not you can actually do them and identify your own mistakes. So this is really what you are getting from like coaching sessions like these. You're like, you might be able to solve leak code problems, but how are you solving them like quickly enough? Are you solving them logically enough? Are you doing it in a way that is pretty consistent and that you can solve any leak code problem? Because it's one thing to be able to solve 400 leak code problems individually because you memorize them. It's another thing to solve 400 leak code problems because you have very good problem solving abilities. Because there's always going to be problems that you have not seen. And the question is whether or not you're prepared for those questions. Okay, Juan asks, apart from asking an interview coming up in 6 weeks, is there some requirement of solved problems before applying? Honestly, like, I want you to really give it a shot of trying everything that's out there on your own before you message me for coaching, because I want people to really be hungry for success. I really want the clients that I work with to work really hard. And in that sense, I want them to think of me as like almost their last resort. Like, I have nowhere else to turn. I need you, Edbert. I need your help. and I don't know what to do, and I'm willing to do anything. I'm willing to work as hard as you want me to. So I don't want there to be any regrets. Like, I want you to give everything a fair shake. I want you to try everything on your own, and I want you to try everything out there before you ask me. Because I feel like the charges I'm doing are relatively high. I'm not gonna lie. But that's also why but I can command that because I am the fucking best. I'm not gonna fucking lie about that. And so I want you to understand that as well. I want you to feel like you can trust me. But like I said, this is also a long-term commitment on my part as well. I'm staking my time and compensation up for that time on your success. And so it's both ways. If you're all in, I'm all in. So, and I want to see that you've put in effort. I'm not going to put in fucking effort for someone to like drop after 3 weeks to say, oh yeah, I tried this other idea, it works, thanks for all your help. But, you know, that's not the kind of people I want to work with. So. Hold on, let me give him a call actually. Okay, let me give him a call. Let me see if I can actually get him online. Give me a sec. Well, I guess he's not picking up. I gave him a fair shake. Guess he's not it. Yeah. So I guess that's pretty much. I guess I'm gonna be. That's it for me. Any final questions from anyone? In the stream. Stay humble, Edbert. Yeah. No, man. Like I had the results to prove it. I have the results to prove that I'm pretty much one of the fucking best out there for when it comes to interview coaching. And you know, like, and I believe in it so much that I'm willing to stake my everything on it. Like, just like the compensation, the time I spend with you, the compensation. I don't get paid unless you get that fucking offer that you want. And in the end, it's worked out pretty freaking well. So, you know, I think the results of my clients speak for themselves. And if you don't agree, you know what? You're welcome to try it out yourself. Like, and I'll do it for, like I said, I do an income share agreement. So if you succeed, I succeed. Yeah. That's how much I believe in it. Now, and if you're welcome to find someone else in the industry who does that, but I guarantee you're not going to find that. So, I guess with that, I guess we'll stop the stream because I'm not getting any more questions, and the other client's not picking up. So, thank you for watching, everyone. Hope you guys learned something from this, and I hope you guys continue to follow me on this channel. Now, if you guys want interview coaching as well and to join this, and if you guys want to, like, you know, follow me on my channel and get some interview coaching, you can book me for interview coaching at echantech.com. Join the Discord. The link is in the description. And yeah, so have a good night, and hopefully I'll get to see all y'all soon.